above and bounded below. When will you say that a set is bounded above and bounded below? You are given a set S, let's suppose this set is said to be bounded from the above side. If you can find a positive integer capital M such that all the members of this S, they are bound by this number from the above side, right? So that means they are less than equal to capital M. Now since we are talking about the numbers, the subsets of real numbers, so all the points lying on the line. So if you are having any bound from the upper side, right, if you can find out this capital M such that all the numbers of the set S, they are less than equal to this number capital M, that means your set is bounded from the above side by the number capital M. This capital M is said to be the upper bound of the set S, right? Is this definition clear? When will you say a set to be bounded above? So you can write down this definition: a subset S of real numbers they are said to be bounded above if there exists a real number K such that every element of the set S, every element of the set S is less than equals to K. Here this K is the upper bound of the set S, right? This K is the upper bound. So you are given any subset of real numbers. These subsets are said to be bounded from above side if you can find out a real number M or K, whatever, such that the whole elements of the set S, they are less than equal to this fixed number K, and this K is said to be an upper bound for the set S. Is this point clear?
Yes, ma'am.
So last time हमने किया interval. Can anybody tell me what will be the upper bound for this interval AB?
B.
Why? Because every number of this interval, this set, is less than equal to B. We know that this set is defined like this. It is a set of all those X such that your X is lying between A and B, including AB. So whole numbers of this set interval, closed interval AB, they are less than equal to B. So this B will become the upper bound for this interval AB. What about in this case? The semi-closed interval?
B.
Again B. But B here, it's not a member of this interval, right? So it means upper bound may or may not belong to the set S. Is this point clear?
Yes, ma'am. Excuse me, ma'am.
Yes.
The upper bound will be a set, right? Like in the closed case from A to B, there will be a set of upper bound from B to infinity. And
Yes,
B
there
will
are.
be the supremum.
Yes, there are infinitely many upper bounds for a given set S if it is bounded from above, right? But I'm talking about this thing ki there may exist an upper bound which may belong to the set or may not. Here in case of closed interval AB, there is a upper bound B which is belonging to the interval AB. However, in this case, B is an upper bound of this interval, but it does not belong to the set. So the upper bound may or may not belong to the set, right? The question is this, the point is this, the upper bound may or may not belong to the set. However, we are having infinitely many upper bounds. Every number after K, every number after k, they all are the upper bound. So k plus epsilon, where epsilon is any positive number, they all are the upper bounds for the set S. If your k is an upper bound, then every number after k will be the upper bound for the set S. So after this, we have a term least upper bound or supremum. So since we are having infinitely many upper bounds from this sets, from this collection, the least value of the upper bound which satisfying this condition, that whole the elements of the set S, they are less than equal to that number is said to be the least upper bound for the set S. Right? What will be the least upper bound for the set S? You are having a collection of upper bounds. From this collection, the least value of the upper bound will become the least upper bound for the set S. Or another way, we can say L to be the least upper bound for the set S if it's satisfying the two conditions. First of all, every element of the set S is less than equal to L. And the second thing, if you choose epsilon to be any number greater than 0, and if you consider this number L minus epsilon, right, a number little bit smaller than L, if this is not an upper bound for the set S, then this then this L is said to be the least upper bound for the set S. Is this point clear?
Yes, ma'am.
Right. So L is any real number. It is said to be the least upper bound for the set S if it's satisfying these two conditions. The first of all, every element of the set should be less than equal to L. Secondly, if you consider any number smaller than L, if that is not an upper bound for the set S, then L will be set to least upper bound of the set S. Right? It is not an upper bound means what? There must exist any element in S such that this y is greater than L minus epsilon. It is not less than equal to, but it is greater than L minus epsilon. It means this is not an upper bound for the set S. Because if it is an upper bound for the set S, every number should be less than equal to this number. But if you can find at least one element from the set S which satisfying this condition, it means this is not an upper bound. Right? So any number L which satisfying these two conditions will become the least upper bound for the set S. Again, least upper bound may or may not belong to the set. Right? This is, you can see with the help of this example. In this case, what will be the least upper bound? It is B, because every number of this interval is less than equal to B. Right? Secondly, if you choose any number less than B, it is not an upper bound. You always find a number which is greater than this number. You can call that number to be as this. You know that this number is greater than B minus 0.5. Right? So you always have a number which belongs to this interval which are greater than this number. So therefore this is not a upper bound for this interval this. Right? So any number smaller than this cannot be a upper bound for the interval this. So therefore this will be the least one such that every number of this set is less than equal to this B. So that means this is the least upper bound of this interval B. And in this case, this least upper bound belongs to the interval AB. However, in this case, the open interval AB, what will be the least upper bound?
B.
Again, it is B, because every number of this interval, every member of this set is less than equal to B. Here it is strictly less than, moreover, strictly less than B, right? But any number smaller than B cannot be a upper bound for the interval AB. So therefore, this will be the least one. So this is the least upper bound for the interval, open interval AB. However, here B does not belong to this open interval AB. So that means least upper bound may or may not belong to the set. Okay. So if you can find out the least upper bound or upper bound for any set S, then that set is said to be bounded above. But if we cannot find out any such number, then that set is said to be unbounded above. Right? So that is unbounded above, or you can say not bounded from above. Can you give any example for this? Any example?
Set of natural numbers.
Yes, the set of natural numbers, they are not bounded from above. We cannot find a number k such that all the natural numbers are less than equals to k, right? So therefore this set is not bounded from above, it is unbounded above. Is this point clear? Clear to everyone? Now the
Yes, ma'am.
next is bounded below. Same way you can define the term bounded below, or you can define a term lower bound. So you are given any subset of real number, right? This subset is said to be bounded below if क्या होगा, all the elements of the set X is greater than equals to some fixed number small m. So if there exists a real number m such that every element of the set X of the set S is greater than equals to m, then this small m will become the lower bound for the set S. So clearly, if your m is the lower bound, every number smaller than this number will become the lower bound for the set S. Okay, every number smaller than this number m minus epsilon will become the lower bound for the set S. So that means there exist infinitely many lower bounds for any set S. For example, in this case, what will be the lower bound?
A.
A. And every number smaller than a minus 1, a minus 2, all these are the lower bounds for this interval AB. Similarly, in this case. Now, the next term is greatest lower bound, or you can say infimum. Let G be any real number, and this G is said to be greatest lower bound or infimum for any set S if G is greater than equals to every other, G is less than equal to X for every X belonging to S, means it is a lower bound. And secondly, for given epsilon greater than 0, if G plus epsilon is not a lower bound. Right? It means there exists some y in S such that your y is less than G plus epsilon. So this is not the lower bound for the set S. Or you can say, if you take a collection of all the lower bounds of the set S, the greatest number in that collection is said to be the greatest lower bound for the set S. Is this point clear? Yes, is it clear to all of you?
Yes, ma'am.
Again, GLB may or may not belong to the set. Right? But there is one term, that is the greatest number or smallest number. Greatest member या smallest member या greatest number or smallest number. So greatest member क्या है? Greatest member of any set S will be what? It is the number. First of all, it should belong to the set S. Secondly, every element of the set S should be less than equal to S. So basically this is an upper bound, but here an upper bound must belong to the set S. If this thing hold, you will say, or you can say least upper bound. अगर लीस्ट अपर बाउंड सेट एस को बिलोंग कर जाता है तो उस सेट में ग्रेटेस्ट मेंबर एग्जिस्ट करेगा एंड दैट ग्रेटेस्ट लीस्ट अपर बाउंड विल बिकम द ग्रेटेस्ट मेंबर ऑफ एस. सो ग्रेटेस्ट मेंबर और लीस्ट अपर बाउंड में डिफरेंस क्या है? लीस्ट अपर बाउंड may or may not belong to the set, however greatest member always belong to the set. ये सेट में बिलोंग करना चाहिए. So if you are having any open interval 0 1, what will be the least upper bound of this interval?
0.
Least upper bound, बच्चे?
1. 1.
1. And what will be the greatest member of this interval? There is no greatest member, right, in this interval. For greatest member के लिए आपको क्या requirement है? That member should belong to the set. Here 1 satisfying this condition, second condition, but 1 is not a member of this interval, so this interval has no greatest member. This point is clear?
Yes, ma'am.
So greatest member और least upper bound में difference क्या है? Least upper bound may or may not belong to the set, however greatest member should belong to the set S. And satisfying this condition that all the elements of the set S should be less than equal to that number G. So that G is said to be the greatest member of S. So open interval 0 1 does not have greatest member. However, if you consider the closed interval, in this case 1 will be the greatest member of this interval. Right? Similarly, you can define a term smallest member. The same way, smallest member, let's suppose we call this as S. So S is said to be the smallest member of set S if first of all S should belongs to S, and secondly all the elements of this capital S will be greater than equal to S. Right? Means this is the greatest lower bound, but this greatest lower bound should belong to the set S. Only then that member is said to be the smallest member of the set S. Right? For example, in this case, what will be the smallest member? Is
No
this that?
smallest member.
Yes. So this interval have no smallest member. However, if you consider the closed interval, it will have smallest member, and that is 0. Is this point clear? What is the meaning of least upper bound, greatest lower bound, smallest, and greatest member?
Yes, ma'am.
Yes, ma'am.
Now tell me, can any set have more than one least upper bound?
No.
No. So you can write down as a remark that least upper bound greatest lower bound, both are unique, right? We cannot have more than one least upper bound or greatest lower bound for any set S, right? So you can write down as a remark that a set cannot have more than one supremum or infimum. Means both are unique. Now let's suppose you are having a set S of the numbers 1 by n, where n is a natural number. Now tell me, is this set is bounded from above? It is a set of all numbers of the form 1 by n, where n is a natural number. Is this set is bounded from above?
Yes, ma'am.
Yes, one.
Yes, ma'am.
What will be the bound? Upper bound?
One.
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 1. Is this a greatest member also?
Yes, ma'am.
Yes, ma'am.
Why it is a greatest member?
Because it belongs to the set.
Yes. And what about the below, bound below? Is it bounded
No,
from below?
ma'am.
It
Yes,
is,
ma'am.
Yes, ma'am.
it
Zero.
is,
Lowest member. Yeah.
Is bounded below by 0.
yes, it is bounded below and it is bounded below by 0. Is 0 a greatest lower bound?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And it is the smallest member also?
No,
No.
No,
ma'am.
ma'am.
No, ma'am.
No. Why not? Because 0 does not belongs to set S. Clear to everyone? So this set is bounded from above as well as bounded from below, right? The least upper bound is 1 and it belongs to set S, so therefore 1 is the greatest member, right? Greatest lower bound is 0, but 0 does not belongs to the set S, therefore 0 is not the smallest member, right? So this point is clear. How to find out the bound from above and bound from below? What is your greatest member? What is your smallest member? Is it clear?
Yes, ma'am.
Now the next definition is bounded. So a set S, which is subset of real number, is said to be bounded if it is bounded from above as well as bounded from below. So any set S is said to be bounded if it is bounded from above as well as bounded from below. It means इस set S का least upper bound भी exist करेगा और greatest lower bound भी exist करेगा. Is this point clear? Is it clear? A set S is said to be bounded if it is bounded from above as well as bounded from below. Is it clear?
Yes, ma'am.
Now tell me, what about the set of rational numbers? Are they bounded?
No, ma'am.
No, ma'am.
Because we cannot find the upper bound as well as the lower bound for the set of rational numbers, right? So this set is not bounded. What about set of positive integers? Are they bounded?
No, ma'am.
No, ma'am.
Are they bounded below?
Yes, ma'am.
Yes, ma'am.
What will be the bound below?
1.
Yes, 1. And every number lower than 1 will become the lower bound for the positive set of integers, right? What about finite set? Is it bounded?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So every finite set is bounded. What will be the lower and upper bound for this set? What will be the lower bound and upper bound for the finite set? The minimum of all and the maximum of all, right? If you denote this set by A, let A be any finite set, then the minimum of A means, or you can say minimum of small a, where A belongs to capital A. So we have to find out the minimum of all the numbers of A. Similarly, we have to find out the maximum of all the numbers of A. That minimum number we can call it as small m, the maximum number we can call as capital M. So the whole numbers of this set A is lying between small n and capital M. So therefore this finite set is bounded by the number small m and capital M. So every finite set is bounded by the minimum number, or you can say by the smallest member of the set A and the greatest member of the set A. This point is clear?